The grid system that Singapore is now in daily contact with. Analyze the existing lattice systems and develop them into their own resilient lattice systems in the 4 directions of residence, transportation, courtyard, and natural ecology. Water mosaic. Resilience grid system of Singapore. Our design makes forward-looking and resilient designs for otherwise inelastic grids. Singapore uses the DTSS large drainage pipe system to recycle wastewater to new water, providing a solution for Singapore's small land and scarce water resources. It can be seen that the river near the base is short and there is no catchment area, and the rainwater flows directly into the sea. In recent years, the Singapore government is preparing to build a second phase DTSS water recycling system near the base. We built the first phase of drainage pipes, rainwater recycling towers and filtration systems in the base, so that the base can have more water resources for the residents to recycle and use, and the excess water can also be transported back to the DTSS system in Singapore for use. It can be seen that the potential advantages of the base are the access to the water area and the connection to the South Park in Singapore, providing people with more diverse water park corridors. Through the recycling water pipeline system under the ground and the linear park above the ground, connecting the base and the North Park connector. We divided the site into these 4 parts, each of which has a different function. Keppel Club, cleaning space, Labrador Park, and power station. Keppel, as a landscape filter water function, passes rainwater and sewage through filtered. Residents can do living, educational, agricultural and recreational uses, while filtered water is transported to parks and power station. The cleaning area, as a wetland park, is connected to the Labrador Park, allowing residents to experience wetland education and sports here. Finally, the water is sent to the power station. The power station serves as a place to use filtered water to filter the land, generate electricity from biogas, and to provide public activities for community residents and to demonstrate the use of filtered water. Finally, the remaining filtered water will be transported back to the new water factory in Singapore through the DTSS system to give back to the society. The first is the Keppel Club area, the main place for living and filtering the water. We designed the Keppel Club into 3 parts: landscape filter system, tower, and flat unit. First is the landscape filter system. The Keppel Club is a golf course, and it can be seen that the base originally had 3 landscapes: irrigation pipe, planting, and pool. And its irrigation system follows the planting area and is connected through the main water pipe and the secondary water pipe. We take this as a design idea. First of all, we keep the pool, and build a landscape filter system on the original main water pipe connection, and insert nodes at the connection to collect and extract water. Next, we design the filtration system based on the original terrain, so that the upper part becomes the collection water area, and the lower part becomes the filtered water collection area. And through the terrain height to create a filter process area. This is our final design. The filter area is integrated into the landscape and divided into 3 parts. The original pipe area became landscape filter system, the node area becomes the collection, the extraction tower, and the pool becomes the catchment area. Looking at the landscape filter system through a perspective view. The primary and secondary filtration are performed through the wetland filtration method. The filtered water can be used for water activities for residents. Have educational, recreational, agricultural purposes. Next is the tower part. Insert nodes from the existing irrigation system of the Keppel Club to collect and pump water to be used as towers. We design towers at nodes, which have the functions of collecting rainwater, storing, structuring, transporting water and people, and connecting to the landscape filtration system. The top umbrella shape is used to collect water. The intermediate water pipe system can transport wastewater and rainwater to the ground. Simple filtration using natural systems during water transport. Finally, the water is sent to the landscape filter system for complete filtration. And finally, our flat unit system. The towers are set up at the node positions as mentioned above, and new flats are formed by connecting to each other. Draw the Keppel main grid and Keppel minor grid according to the water pipe connection of the tower to determine the flat massing. This is our new Keppel plan plus flat system. Water is used as a medium that blurs spaces and people. Water makes these zones formed by different kinds of opportunities to rethink the life of flats. In the process of water flowing to the ground floor, the buffer space between flats can also be activity spaces for residents while water filtering. Disengage every single space and insert new activities between these blank space. These pipes connect spaces related to water. Water becomes the core of flat unit. This is the section of our living space in the Keppel area, combining the 3 systems through the terrain. They are the landscape filter system, the tower, and the flat unit. They have different functions. First, collect rainwater and sewage water, send it to the landscape filtering system for a filtration. After the filtration is completed, it is filtered again. The water after the secondary filtration is sent to the catchment area and passed back to the flat above through the tower for use by the residents. Also give back to the city through the DTSS system. Based on Keppel Club, then pull out the average line of buildings, towers, parking spaces, etc. with a 50-meter grid. Develop 48 and 24-meter grid lines with the size of Singapore parking spaces. Next is Wetland Park. The original river channel of the Wetland Park was naturally meandering, and the project of cutting and straightening was carried out in 1943. The current straight river lacks an ecological buffer zone, and is the interface between Keppel, Labrador Park, and the power plant. The main concept of the mosaic made in the previous stage is used. Wetland Park can filter surface runoff and underground permeable water layer at the same time. We create canals through mosaic segmentation. This mosaic-shaped diagram, based on the percolation principle with dissipative forces, opens a complex web of undetermined channels for the flows. The power station. Power Station A is planned as a greenhouse workshop and education area, and the Power Station B is reinterpreted as a biogas power station. The top area is connected by a linear park, combined with a bicycle path and outdoor sports area, and the two power stations are connected by the sky bridge and the water tower systems and guide visitors to enter. Use towers to collect rainwater, use excess rainwater and wastewater from other areas to generate electricity with biogas, and transport excess wastewater back to the underground DTSS system. Plant plants with different growth rates on the land according to the level of pollution. Fast-growing plants can purify the land faster and affect the number of recycling. Biogas generation is used for linear parks and sidewalk lighting. Excess electricity is stored for emergency use and transported back to other power plants. This is our power station energy plan. 41.5 tons of crops waste can be used to generate electricity, and about 30,960 kilowatt-hours of electricity can be generated by biogas power generation once harvested. 8.754 metric tons of rainwater can be collected by tower in a year and combined with wastewater can produce 52,720 kilowatt-hours of electricity. The power station area is mainly connected with linear parks and skybridge, bike path and other sports and leisure facilities are provided on the linear park. Use the sky bridge to bring visitors into the interior from the facade windows of Power Station A, while Power Station A provides plant workshops, food education, and show. The tower of the power station can be divided into rainwater collection, emergency water storage use, irrigation and wastewater recycling and electric lighting system, and the interior of the tower can also become rest area and exhibition area. Power Station B is used for biogas power generation. The main materials will be polluted crops and wastewater from the site, and can be entranced by the skybridge. Display and observation mezzanine can see the internal operation. This is our final design. Replanning of the 4-zone and water system. The filtration system in the Keppel residential area will filter the water for the residents to use. The water tower of the power plant, the plants that absorb pollution and a part of the residential wastewater will generate electricity for the power plant. The excess wastewater from the power plant and the residential area will then enter the Singapore DTSS system. In addition, it will be used for 4 reclaimed water plants in Singapore.